the derivative of a function f of x at the point a is denoted by f prime of a and is equal the limit as x approach a, f of x minus f of a all over x minus a. And you might notice that that limit looks like the definition of the slope of a tangent line. And you are correct. They look the same and they are essentially the same, except now you have a new name. It's called the derivative. And the advantage of using this notation is that you can see what the point A is. So compared to the slope m, it just equal a number. You don't see what that A is. So now it gives us a point to reference. So alternatively, you may also define the derivative f prime of a equals the limit as h approach 0, f of a plus h minus f of a all over h. These two are equivalent definition, but calculation-wise, you might find it easier to use 3.5 this definition most of the time, because you evaluate f of a, which is just a number, and then f of x is just a function. On the other hand, if you need to evaluate f of a plus h, and in our case, in our example, if you have a polynomial, you might have to do a lot of expansion. So I would recommend you to choose 3.5 most of the time to begin with that definition in order to find the derivative of f at a point. So now let's take a look at our function. 3x squared minus 4x plus 1, we want to find f prime of 2. So we use the definition f prime of 2 equal limit as x approach a is 2 in this case, f of x minus f of 2 divided by x minus 2. Now you plug in the function. So limit as x approach 2, f of x is 3x squared minus 4x plus 1 minus, so what is f of 2? F of 2 equal 3 times 2 squared, which is 3 times 4, right? 12 minus 4 times 2, which is 12 minus 8, 4, then plus 1 equals 5. So f of 2 equals 5. And you continue with the rest of the limit. So now on the top, we have to simplify. So we have limit as x approach 2. 1 minus 5 is negative 4. So it's 3x squared minus 4x minus 4 divided by x minus 2. Then you might need to use direct substitution, but you will realize that direct substitution doesn't work. It gives you a 0 in the denominator. So you will need to factor the numerator. So how do we factor the numerator? If you don't remember the factoring technique, you might need to go back to chapter 1 to refresh, or just Google some factoring video. Now, there's one easy way to be able to factor this is you use a quadratic formula. It will work all the time. But we know how to factor, so we don't really have to use a quadratic formula and calculate a bunch of numbers and then put it under the square root. Okay, so now we want to factor the numerator, and the denominator is just going to be x minus 2. The first thing we factor is 3x squared. Well, naturally, 3 is just 1 times 3. So we get x, and we have 3x. And how do we factor 4? Well, we can factor negative 4 in this case. We can factor negative 4 as negative 1 times 4, negative 2 times 2, and 1 times negative 4. So you just need to play around and to realize that 2 times 3 is 6. 6 minus 2 is 4. So if you factor it this way, you have negative 6x, and then plus 2x is going to give you the negative 4x. And negative 2 times 2 is negative 4. So that is our factoring. And surprise, x minus 2 cancel with x minus 2. And that actually is going to give you a hint of how you're going to be able to factor. If the limit exists, we'd better be able to cancel the denominator. So that will give you a hint of one of the factor. So now what is left? It's just limit x approach to 3x plus 2. And in this case, we can do direct substitution because there's no zero denominator. So we get 3 times 2 plus 2 equals 8. What it tells us is that f prime of 2 equals 8. So the derivative at a point, and the point is a is a constant, it's going to give you a number. So you can think of derivative as a number if you're given the point. And next we're going to study the derivative as a function.